Dear friends, welcome to Civil Conclave presentation. Today, we are going to talk about how to do the reinforcement detailing in the structural works based on code number IS456-2000 and IS13920. Okay, this is what the detailing we are going to talk about. Who is an engineer? The liability of the engineer compared to any other profession is that his works are out in the open where anyone can see them. He cannot bury his mistake that in the grave like a doctor's. He cannot be like an architect, cover his figures with the trees. The design engineer responsibility should include ensuring the structural safety, design, details, checking, shop drawing. Detailing is a very important and plays a crucial role. This means this detailing will enable the site engineers to understand what you are trying to say. Accordingly, you can execute. The requirement of the good detailing should be simple for a fabrication and a placing. Check spacing for crack control, that's the maximum spacing. Minimum spacing for a concreting placing. Check the splicing requirements and development length. Care for a section for varying depth and slope slabs. Care for corner joints, beam column joints, and openings, etc. Detailing for a gravity loads is different from the lateral loads, especially for the seismic forces. Apart from the detailing for the above, there is a different detailing required for a rehabilitation and strengthening of the damaged structure. Detailing codes SP16 and IS456-2000. European code 13 EQ code is 13920 is for a seismic forces. Minimum cover for a concreting in the reinforcement. To develop the desired bond strength throughout the perimeter of the steel. To protect against the corrosion and the fire. The nominal cover will be always for a slab will be 20 mm, beam will be 25 mm, column will be 40 mm, footing will be 60 mm. For other details, you can see the table 16 of IS 456. Spacing of the reinforcement. The horizontal distances, I mean to say the horizontal means which is going to the parallel. Reinforcement shall not be less than the diameter of the bar if in case if the bars are equal diameter. If it is the dia of the larger bar, if there is a two different type of bars. Plus or minus, that is a 5 mm plus of the nominal size of the aggregate. If it is supposed to be 20 mm metal, you should have a minimum 25 mm. Maximum spacing as per design. You can refer AK Jain book also. Limits of the reinforcement, that is class 26.5 IS 456-2000. You can verify, which will verify. Beam minimum bending length will be 0.85 divided by F5. Maximum will be 4% of bending. Compression should be 0.2%. Web reinforcement shall be 0.1% of the web area. Vertical shear bar not exceeding 75 dia or 300 mm, whichever is less. Minimum shear bars clearance will be 26.516. You can verify it. Slab minimum 12% for FE 415 and 15% for Fe250. The stirrup shall be minimum dia of 8 mm in case of a lateral road resistance. The hooks shall be bent at 135 degrees to resist the earthquake split up. In column size, the bar should not be less than 12 mm. Spacing of the bar should not be greater than 300 mm. Arrangement of the lateral ties shall be as per IS456 class number 26.5.3.2. See, development length of the bar, here I am explaining in a detailed table. If it is the 8 mm bar, that is what you call now, yield stress will be 415, Fi of 415. If it is the 8 mm bar, in tension it should be 376 mm. Whereas in compression, it should be 301 mm. If it is a 16 dia, in tension it will be 752 mm. In compression will be 602 mm. If it is a 25 mm, in tension it will be 1175 mm, whereas in compression is 940 mm. In 32 dia bar, in tension it will be 1504, whereas in compression 1203. Generally, we use 50 dia for the tension. That is if it is under 10 mm, it will be 500 mm. So this is a 50 dia will be used for a tension. See, this is the methodology of making a splicing. Here you can see how the splicing. You have to juggle it out and enter like this. Here you can see the splicing. This is based on class number 26251. Okay. Lap slicers should not be used, wherever there is a lap length should not be used if the bar is more than 36 mm dia. In case if it is 36 mm dia, it should be welded. Lap length including anchorage, value of hooks in fractional tension is development length, that is a LD or a 30 kp, whichever is greater. Lap length including anchorage value of hooks in direct tension is 2 LD. The straight lap length should not be less than 200 mm or 15 dia, which is greater. Lap slices are considered should be as a staggered one. If the center to center distance of the space is not less than 1.3 times of the lap length. The lap length is in compression shall be equal to the development length in compression, but not less than 24 dia. Lap length is calculated on the basis of the diameter of a smaller bar when bars are different diameters are to be spliced. What are the things you have to look for a detailing? Prepare the detailed drawing in a proper fashion and accurate. Prepare bar bending schedule. Indicate proper cover to the reinforcement. Decide the location of the openings, holes, and adequate details in the reinforcement around the opening so that a site engineer can understand properly. Commonly available sizes of the bars and spiral shall be used for a reinforcement. For a structural member, the number of different sizes of the reinforcement bar should be a minimum. The grade of the reinforcement should be clearly mentioned in the structural drawing. When reinforcement is left exposed for a future construction, it should be adequately protected for a corrosion and weathering. Congestion of the reinforcement should be avoided at points where you can provide a pin, etc., so that there won't be any congestion. So enlarged detail, and our structural consultant is supposed to show the enlarged details of the corners, beams, and column joint and at special location. Do not do these things in the following detail. Flexural reinforcement shall not be terminated in a tension node. Lap slices should not be used for a bars which is more than 36 mm. Different types of reinforcement bar, such as deformed bars and plain bars, and various grades should be used side by side, as this practice would lead to confusion in the site. Do for the column. A reinforcement for the column should have a minimum 4 for a rectangular, 6 numbers for a circular column. Keep outer dimension of the column as a constant as far as it's possible, so that your shuttering can be reused without any damages. Preferably, avoid use of two grades of vertical bars in the same element. What I mean to say, the bottom will be FE500, the top will be FE415. Don't. If you are FE415, continue with the FE415. If it is FE500, continue with the FE500. Do's for the beams and the slabs. Wherever the splices are provided in the reinforcement bar, they should be staggered away from the section of minimum stress. Where the beam depth exceeds 750 mm, in case of a beam without a torsion, and 450 mm with the torsion, side face reinforcement should be provided. All splicing shall be CC to center spacing of the bars. You can note that in the drawing, CC, that means center to center. Deflection in beams, slabs may be reduced by providing compression reinforcement. What I'm trying to say, if you provide your compression reinforcement, your deflection can be minimized. All beam column intersection, the main bars avoid to the main column bars. At beam intersection, main reinforcement should be so arranged that the layers in mutually perpendicular beams are at different levels. To accommodate the bottom bars, it is good practice to make secondary beams shallower. That means secondary beam should be deeper than the main beam, at least by 50 mm. Curtailment of the reinforcement. Flexural reinforcement shall not be terminated in a tension zone unless the following conditions are met. Shear capacity at the end of the bar is 1.5 times of the applied shear. Stirrups areas in excess of that required for a shear, and a torsion is provided over the distance equal to 75D from each cutoff point. That is, A is equal to 0.4 Bx alpha y, where X is equal to D by 8 beta B, where beta B is the ratio of area of a long bar cut off to the area. Refer class number 26.2.3 of IS456. For 36 mm and smaller bars, the following should be satisfied at the end of the bar cutout. Area of the continuing bar should be at least twice that required to resist the bending moment. Positive moment of the reinforcement has been mentioned in 26.223. Negative bending moment is again mentioned in the same classes. Curtailment of the bundle bar is equal to class number 126.2.35. You can refer AKJ in books, page number 172. Simplified rules of curtailment, you can verify British Standard 8110 1985. Bar bending schedule should include identification of the structural member, position of each member, bar marks on the dia of the bar, number of the bar, shapes and bending of the bars, length of each bar, remarks. For example, you can refer AKJ in book, page number 180. IS13920 1993, ductile detailing for an RCC structure for a seismic forces. This code is applied to all RCC structure which satisfy one of the four conditions. It should be ZIN 4 or 5, zone 3 and I greater than 10. Okay. In zone 3 an industrial structure. In zone 3 and more than 5-story height. What is the earthquake resistant design? The acceptable response levels of the structure under design earthquake, designer should exercise some degree of a control on magnitude and distribution of a stiffness, mass and relative strength of the member, and their ductility to achieve desired result. Seismic design, which is mentioned IS 1893. Minor. Desired behavior, no damage to the non-structural member. Controlling parameter, controlled reflection by providing stiffness. Moderate. No significant structural damages. Minor cracks in beams and columns. Okay. Avoid yielding of members or a permanent damage by providing a strength. Severe, catastrophic. No collapse of the system which would cause loss of a life. Allow structure to enter into in realistic range and absorb energy by providing ductility. If elastic strength of the structural elements exceeds the greater imposed load upon that, the structure can be significant damage. In severe earthquakes, some of the resisting elements will be loaded to the full strength. If they are brittle, they will fall, throwing their share of the load in the remaining elements. If they are ductile, they can continue to participate in resisting the lateral force up to the full strength after they yield. Ductility. A ductile material is the one which can undergo a large strains while resisting loads. Ductility implies the ability to sustain significant realistic deformations prior to collapse. Brittle material is one that fails suddenly upon attaining its maximum load. Here you can see this image where you can understand this. X-axis is the force, Y-axis is the deformation. See here, see the ductile will be continued, whereas the brittle will break here. Okay, now I think so you got it the point of my head. Member of structural ductility is defined as the ratio of the absolute deformation to the corresponding yield deformation with respect to the displacement. It can be expressed in terms of curvature and the rotation. Strain based on the ductility almost depend upon the material, while rotation, or a curvature based on ductility, which also includes the effects of the shapes and sizes of the cross section. Significance of the ductility. It can be accepted to adopt an unexpected overloads, impact on structural movements due to foundation, settlements, volume changes. Occupants will have sufficient warning of the impending failure, thus reducing the profitability of the life in the events of collapse. All joints splice should be able to withstand forces and deformations corresponding to the yielding of the reinforcement. Design of ductility. Structural layout should be simple and regular. Amount of tension reinforcement in beam should be restricted and more compression reinforcement should be provided. Beams and columns in a reinforced concreting frame should be designed in such a manner that in elasticity is confined to beams only and the column should remain elastic. To ensure that moment capacities of columns and beam column joints should be greater than that of the moment capacities of the beam along with each principal plane of design axial loads. The shear reinforcement should be adequate to ensure that the strength in the shear exceeds the strength in the flexure, and that to prevent non-ductile shear failure before the fully reversible flexural strength of a member has been developed. You can refer class number 6.3.3 in IS 13920. Beams. At least two bars should be provided continuously both at the top and the bottom of the beam. The positive moment of the reinforcement should be at the face of the joint, should not be less than 1.5 of the negative moment resistance provided at that face of the joint. Neither the negative nor positive resistance at any section along the member length should be not less than 1/4 of the moment resistance provided at the face of any other joint. Refer class number 6, IS 13920. Here you can see the beam reinforcement. I try to show you as much I can understand. See, this is a cover, that is a fixation. This is a 2D. There's a hoop spacing, you require a 2D. Okay. Development divided by 4 and 8D by B is the things here. B is equal to breadth of the beam. DB is equal to diameter of the rectangular beam. Okay. Here I try to show you how these things has been worked out. Spacing of the hoops over a length of 2 dia at either end of the beam shall not exceed D by 4. 8 times of the diameter of the smaller longitudinal bar need not be less than 100 mm. Elsewhere, the beam shall have vertical hoops at a spacing not exceeding D by 2. Refer class 3, 6.3.5 of IS 13920. Column. Fractured axial stress shall not exceed 0.1 FCK. Minimum dimension of the member is 200 mm. If the CC center to center distance of the beam exceed 5 meter or unsupported length of the column exceed 4 meter, minimum dimension is 300 mm. Ratio of the short to perpendicular dimension shall not be less than 0.4. Refer class number 7.2 and 7.2 of IS 13920. The special confining reinforcement shall be provided above and below the beam connections in a length of the column at each end which is largest the following: 1/6 of the clear height of the column, larger dimension of the column, or a 450 mm. When a column terminates into a footing, special confining reinforcement shall extend at least 300 mm into the footing, like this. You can see here. Here, special confining reinforcement. See, this is what is called as special confining. It should be minimum 300 mm. Okay. Here I have shown you the entire column beam joints, how the splicing has to be provided, transfer of reinforcement, special confining reinforcement, confined joint with the beams and framing and all sides, etc. Everything has been shown in this things. This is as per IS 81. The spacing of the hoops should be special confining reinforcement shall not exceed 1/4 of the minimum member, need not to be less than 75 mm and not more than 100 mm. For further information, you can refer class 746-747 of IS 13920. Here, the anchorage of the beam length, how it is to be used, you see here. LD plus 10 dia. That means development length plus 10 dia. LD plus 10 dia. This is a development length which has been shown. LD is the development length in the tension. DB is equal to bar diameter. Okay. It is for an external joints. Last places in the beam. Not more than 50% of the bar shall be spliced in one section. Longitudinal bars shall be spliced, only hoops are provided over the entire specializing, not exceeding 150 mm. The lap length shall not be less than the bar development length in tension. You can refer class 626 of IS13920. Lap slices shall not be provided within a distance of 2 dia from the joint face, or within the joint, or within the quarter length of the member, where flexural yielding may generally occur under the effect of the earthquake forces. Use of welded splices and mechanical connections may also be made as per IS456-1978. Refer class number 6.26 IS13920. Here I show you. See, this is the LD, that is the development length. Okay. This should be not greater than 150 mm. LD means development length in the tension. DB is equal to diameter of the bar. I hope so. I clear how the splicing in the beam should be done in the beams. Web reinforcement consists of vertical hoops, stirrups having 135-degree yoke within 10 diameter extension, but not less than 75 mm each end. Also use stirrups with a 135-degree hook and 10 dB, that is a bar dia extension, but not less than 75 mm at each end. Minimum dia of the bar forming hoop is 6 mm, but beam clear span is greater than 5 mm. Shear forces is to be resisted by vertical hoops. Its maximum is calculated factored shear force and a reinforcement given. Here I given all the calculations of the drawings, how the hook length has to be provided, use stirrups how to provided, and how the cross-aisle has been provided, hoop, how it is, what is called as a hoop. Everything has been explained in this sketch. See the bib, it is a 300 mm, that is a 300 by 300 mm size. This is a 10 dia, that is a 75 mm. H shall be larger than H and BC. You understood what I mean to say? H is larger than HC. Like this, here I provide the reinforcement of cross-light reinforcement, how it is provided. All these things has been explained in these sketches. Cantilever beam. This is a crack joint. This is incorrect. Okay. Why it has been incorrect? The reinforcement has been continued. The actual procedure has to be like this. You have to have a closed stirrups. This is known as a correct. LD by 2 will be the closed stirrups. Non-prismatic beam. This is again wrong. Why it has been wrong? Again, the reinforcement stirrups is not LD by 2 on both the dimension. Hanger bars. Here, the hanger bars, the beams has been as level equivalent to the beam, whereas it should be little bit above and with a camper. Here I show you extra bars how to provide, etc. Main secondary beams. Here you can see the secondary beam which has been tied wrongly, but whereas it should be like this. Okay. Beam 1/4 or a 1/5 of the spin. This is incorrect. Okay, you can see it here. This is supposed to come up to here and it is up to the LD. This is wrong. Actually, here what I say, this methodology is wrong. This methodology is right. It has to come in. Continuous beam, again, how to be correction details and everything. In all these sketches, I try to explain what is the correct method of detailing. Better study it in depth and understand it. Non-prismatic section, again, the same problem. Here, the close rings has been not provided here, which is a wrong practice. Cantilever beam. Cantilever beam, again, you see, this is the beam rods has been come down here. It has been cut down at here. Actually, these bars should come further below. Okay, this is a development length, not less than 5 LD. Okay, this is the correct position. This is a methodology of how to provide a cantilever reinforcement. In the slope roof slab, again it is wrong. It has been taken likely. No, it has to be taken like this only. The bar has to come across and go 1 LD. Like that it is go. This is a methodology of providing a sloping beam reinforcement. Haunch beams, the same methodology of development length. Compression and tension. Stresses at the corners. Here you can see how the reinforcement has been react. Okay. Standard torsion in the bars. Skin reinforcement 10 dia is required when depth is exceed 450 mm. That is 1% of the 0.1% of the web area. Cantilever with a point load. See, this is wrong. Actually, this is the correct methodology. Even here, the reinforcement has to come like this. Okay. Opening in web beam. Always there is a these corner protection reinforcement has to be provided wherever there is an opening has been there. Beam column extension. Here you can see this beam column extension. Beam is actually it has to be like this. LD, the tension bar. Closed stirrups has to be provided. Splice details. It straight vertical is always wrong. It should be 1/6 of the length should be slope is to 1:6, bend and then cover it up. Again, reduction column on both the sides is wrong. It's always reduction from the both the side. It has to come back and brought back to a normal portion. The slope should be 1:8 from beam bottom. Again, termination of the column bars at the top. This is a wrong methodology, correct method. This bars has to be taken up and L by D, it has to be bent up. First stirrup should be 50 mm from the beam, minimum. Spacing of the reinforcement in a shear has been shown here. Spacing of the reinforcement in the columns has been shown here. Continuous beams, again the reinforcement. The closed reinforcements will be 2 dia. Okay. The footing methodology. Here you can see the footing methodology has been absolutely wrong. This has to go the LD. Okay. Then you have to bend back. And these column bars has to come inside the footing. And here additional reinforcement has to be provided. Okay. Trench. Trench, if you are not providing the reinforcement like this is the area the crack will appear. Okay. Staircase, Way Sla. Here, generally, this is the wrong methodology. The reinforcement has to go back in the Way Slab and bend back. Okay, LD minimum. Slabless staircases, it will be like this. Okay. I try to explain how to do the detailing of the entire reinforcement through this presentation. In case of any queries, you can write to me at civilconclave@gmail.com or at my Telegram group, Civil Conclave Telegram group. The link has been provided here. Kindly share, subscribe, like, and share with your friends so that it can also enable to understand the subject thoroughly. In case of any queries, do not hesitate to write to me. Once again, I'm taking this opportunity to thank you for very much for watching this presentation. Kindly like and subscribe. Thank you.